Okay.
Oh, I love Fruity Pebbles.
All right.
What's wrong with you? Why would you raise cereal?
So, okay. All right. So here's the idea. Let me pop it up on the projector here. We're gonna have formulas for. I put those controllers. We're gonna have formulas for perimeter, surface area, and volume. I want you to have those down today. I'm gonna pop them up so they're really big in front of you. It's just one of those things you just need to see it. Let me throw this up on the projector here. All right. Pop it up here.
Oh, I'm tired. Nice to meet you.
Good. Now let me zoom on that. Okay. This is the thing I was showing you yesterday, but I didn't let you write it down. That should be big enough, I think. Whoa. All right. It does not want me to show you this today. Like, no, don't. Oh my goodness. All right, there you go. These are the main 5 that we're going to probably have on the test or homework. There is more formulas in this. It's just these are the main ones that are easy enough to calculate that it's not super difficult. These are the ones that, like in ACT, MAPS testing, Iowa Test Basic Skill, these are ones they kind of go towards. They lean to these first. There's other ones, but these are the ones that they're going to probably have some form of question on. That's the hardest part, I think, of like the MAPS test that we've taken the last couple of years, if you've never taken it freshman. MAPS is this automated test that we give in a couple different subjects, but math is one of them, where it adapts to your knowledge. So like when you're doing really well, it gives you problems that are trying to increase to see what level you're at. It's actually a really smart test. If you get a question wrong, it gives you the question differently, or maybe gives you a little bit easier attempt at it, and then if you get it right, then it moves on to the next question difficulty. So it narrows down like how much you know in math. Well, it's really clever. Well, the hardest part of those tests that I felt because I actually took it too, just to see what the test was like, was this part. It was like, oh, here's a sphere, what's the volume of it? I didn't know the formula. Like, I would have to think about that formula to know it. And then you print it on the test, you just had to kind of know it. So, okay, fair enough. But yeah, so prism, regular pyramid, so that's a rectangular pyramid. So they call it a regular because it actually has a square base to it. But it doesn't have to be, it could be a rectangular pyramid. But they want all the triangles to be the same. That's kind of what they were shooting for. That's why they give you a regular. Cylinder, the cone, and the sphere. Now, what all these things are, like what you're looking at here, these are the formulas for surface area. That's why they have an S. That's surface area. So that's surface area of like this room is how much paint you'd have on the walls. That's surface area. It's like the actual spacing on the floor. The floor has surface area. It's how many tiles fit on the surface, right? We did that calculation yesterday where it was like this room is 24 by 26 tiles. Well, that's the surface area of the floor if they're measured in feet, maybe. So it would be 624 feet square feet. Well, that's just the surface area of the floor. You have to add the walls in and the ceiling. You have to add all the parts. But this formula is how they actually calculate it. Now, all the key is down below, like what these all stand for. And so, I don't know how far we got yesterday, but I'll do the example of the prism today. I'll do one example. That's what I want to do. Okay, and a lot of you are trying to write down all the formulas, which is fine. Now this chart is in your textbook, it is in there, so I'll show you the page where I found it and stuff. But these are the main 5. They had more. I just picked the main ones I wanted. Ones I'll probably put on a test. And on Monday we'll probably walk through the pyramid one. I'll show you like if it's not regular, how would you attempt that problem? Everyone good? Everyone's got, for the most part, the formulas down? Okay, all right, let's talk about let's do the box. Let's assume that this room is like a perfect rectangular prism. I know that that back door area has kind of weird walls. So here's my room, three-dimensionally. Okay, the room was 26 by 24, and let's say that's in feet. Say that's feet. I don't know if these blocks are exactly 1 foot, they kind of look kind of close to it. So 26 by 24, that's the base, like the dimensions, length and width. And then the height of the room is 10 feet. Ceilings are usually 10 feet in public buildings. Okay. All right, so let's go through and let's talk about how to find surface area of this room, right? So what they're saying is that you need to find P first, that's the perimeter of the base. Fair enough, perimeter is like the walls all added up. So perimeter for mine, so P is adding 24 plus 26 plus 24 plus 26. It's going around the outside of the walls and adding up all 4 walls. Because again, I'm just walking around the bottom of the room. So like in this room, 24, 26, 24, 26, all the way around. So that's the perimeter, it's the floor, like the fence line. This adds up to be 100. So that's 100 feet for perimeter. We feel comfortable with how we find perimeter, you just add up the walls. Notice I didn't add the 10 in there. The 10 is the height. We're not using that for perimeter. We just use the walls. Okay, now we have to use height next. So the height of my room is the next thing. So we're going to take my 100 perimeter, my 100 feet, and we're going to take that times how tall the room is. The room is 10 feet tall. So it's 100 feet times 10 feet. If we multiply feet by feet, you get feet squared or square feet. And we're going to add that to twice whatever the base is. Now the base is, the B in this case is the area of the floor. That's the base, the floor that you're standing on. Well, how do you find area of a rectangle? We talked about this yesterday. Area of a floor is where you take 24 times the 26. This is looking top down in the room, like top, like I'm on the ceiling looking down. So to find area, you actually take the bases and you multiply these together. Well, we did that yesterday. That was the 624. And that would have been in feet. Feet squared, I should say, feet squared. So it was 24 feet by 26 feet, and we got 624 feet squared. That was the area, by multiplying those two together. Does everyone understand how I found the area of the base? Rectangles are really length times width, that's how you find it. And then once I have these, then I can add the two numbers together. So I'm actually, to find the total surface area, so total surface area, you take the 100 times 10, which is 1,000, and then we're going to add the 2 times 624, which is an 8, 4, it's 1248. So that's taking 624 times 2, and now I'm going to add these together, so I get 2,248, and that's feet squared. That's the total surface area. But I want to talk about why. I want to talk about like, well, why is that a thing? Okay. Like, why is that formula giving me my total surface area? Because that's, so if I was like painting the whole room, let's say I was painting the floor, the ceilings, the walls, that's how much, that's this total surface area. So if I was going for cans of paint, I could look at that and go, okay, one can covers 500 square feet, because they say it on the can how much it will cover. So then I can go, okay, well I need more than one, because it only covers 500, so I might need 4 to get to 2,000. And then I might need another one to get to 2,500, so I might need 5 cans of paint. So that kind of helps me estimate what I need. That's surface area, is how much you can paint. Now obviously we wouldn't paint the floor or the ceiling, but you get the idea. The one thing, like why this formula works, basically what they did for the first part, they had you find perimeter, and then you took it times the height. What they did is they basically took the room and ripped it open like a pop can. They just tore the walls off, and they took all of these walls, the actual walls of the room, and they stretched them like this. They put them side by side by side. They just like ripped the room open and they put them all next to each other. The perimeter is all of these added together. That's where that 100 came from. And then they took it times how tall it is, which is the 10. Well, that makes sense. That's a total area of the all four walls just put side by side by side. Does that make sense? Like why they did that? Because that's length times width. Times width. That's what they did. And then why they did the second part, the 2B. Well, they're finding the area of the base, which is the floor, but then they multiplied it by 2. Why'd they take the area of the floor and multiply by 2?
Because there's another one.
Yeah, there's another one. You have the ceiling, which is the exact same dimensions. It should be the same. So if you found the area of the floor, duh, twice of it should be the total area of the ceiling. And then they added the two together. So the floor of the ceiling plus all four walls. That's why this number is the total surface area. Now volume is different. Volume, instead of feet squared, square little tiles on the surface, volume is how many desks I could fit in the room, or bales of hay. Like that's how I think of it. It's how many objects could I put in the room itself. So what you do on this one's pretty easy. They say you take the area of the base times how tall it is. Well, we already found the area of the base. The base was the 624 feet squared. And we take it times how tall that room is. The room is 10 feet tall. So if you actually multiply that, the volume of the room, is 6,240 feet cubed, cubic feet. It's how many, so if you were to take perfect cubes that were made of 1 foot by 1 foot by 1 foot, you would have 6,000 of them that would fit in this room. So that'd be like this tile, but going up and making like a perfect little box for that tile. So you'd have 6,000 of those boxes, 6,240. Now, why they do that? The volume, I should say, for any cubic thing is length times width times height. Now, height can be replaced with depth. That's the same thing. So it's three-dimensional. That's why it's feet cubed. There's 3 dimensions to it, not just 2. Not just the length and the width. But yeah, so that's the idea. I think the reason I always do this one first, that's the one we're doing today, is that you can apply the volume thing to any shape. So if we went to the cylinder, right? The volume of the cylinder. Really, I know the formulas look more complicated, but it's the same concept. You find the volume of the base, or the area of the base. So like on a cylinder, imagine that it was a stack of CDs. If you ever, I don't even know if you guys ever had to do that. Did you guys ever have to buy a stack of CDs that you can burn music on?
Yeah.
Okay, I didn't even know if you guys ever had to do that in your life. But they sell you a stack of CDs, right? What you do is you find the surface area of the bottom CD, or how much data it can hold, and you take it times how many CDs you have stacked on top of each other. So the area of the CD, the depth, how much data it can hold, times how many CDs you have stacked, is the total volume. It's how much data you can put on all the disks at once. In fact, buying disks like that, where you have the bottom one is I think 5 gigs. That's usually what it can hold, and then you multiply it by the 100 disks that you had on top of it. Well, that's 500 gigabytes worth of data. 5 gigs times 100 disks is 500 gigs. It was actually cheaper way back when I was in high school to buy CDs than it was to buy a hard drive. Nowadays, it's totally flip-flopped. You can go in a store, buy a really big hard drive to put music on, and that's cheaper than the disc itself. The discs are made of plastic, so it costs more money for the oil-based products that they use in it. So I'd always recommend buy a hard drive now, and look for the solid state. Don't get a spindle drive that has needles, where it says 5,400 RPMs or 7,200 RPMs, avoid those. If you want to go solid state, they're way faster. But yeah, so back when I was in school, buying disc was the common thing. I would actually back up all my data, my Word documents, my files that I had. I would actually back them up on discs, burn those files onto a disc, because it was cheaper than buying a whole hard drive. It was just hard drives are crazy expensive. You guys are lucky, you can go to a store, buy a hard drive for $50, and it could hold 500 gigs worth of data. Back when I was doing it, those were $300 drives. I don't want to pay $300 for a stupid hard drive that had 500 gigs on it. Data's definitely changed. You guys are lucky, your computers you buy anymore come default with 100 gigs worth of storage. That's kind of normal, 128. do you need?
I just want to know where I'm supposed to go for the judges.
Oh, judges, we'll meet in the office.
Alright, can I just sit here then?
Yeah, why you had a class like 10 minutes ago?
Because I was bored.
Alright, but yeah, so the idea was that buying hard drives, like, the amounts have changed. To give you an idea, my first computer I bought my freshman year of high school. Freshman year. And I bought the most expensive computer at the time. It was stupid, don't do that. But I bought the most expensive computer at the time. It was for a laptop. It had the biggest screen ever that ever came out in a laptop. It was 15.6 inches. That's pretty normal now. But that was the biggest screen that ever came out before. The hard drive was 5 gigabytes. 5 gigs. That was, by the way, that was big. That computer cost me $2,500. Yeah, nowadays you laugh, you're like, 5 gigs? That's like my RAM that I put in the computer now, right? Yeah, my phone now has 256 gigs. My phone has more than my original computer, like back in 1995. Because that's data, like drives, were crazy stupid expensive. Nowadays you can buy like a beefy computer for cheap. That would be a billion times the size of the computers back in the 96 era. But the files that we also had were not that big. File sizes have grown. Games weren't 50 gigabytes in size to install a game, right? Games came in floppy disks and CDs. They were less than 5 gigs to install them. Like, it was just a different era, a different style of game. But yeah, these are like things that apply to it, right? These objects are something you deal with all the time. Solid state drives, instead of like the disk drives, are these. They store the data in blocks. So it's way faster to access, as opposed to a spindle drive that has to spin it like a record with a needle on it that reads the data that's slower, because it has to find where it's at. So it's just like, you guys are lucky at this point in your life. You guys don't have to deal with that issue. But any questions on any of the kind of the intro day? All right, we're done for the day. It's pretty easy. I just want to make it pretty light, pretty easy for you.